Hi class, let's take a look at example 5. So in example 5, we can tell that this is a Poisson because the interval happens to be technically 1 year. And as we mentioned earlier, well, once you determine that you have a Poisson event, these are the formulas that we're going to be using. So in this particular scenario, the actual value of the mean, it's going to be given as 116 divided by 365. Some of the problems on the homework are going to want this as an exact answer. So let me use a decimal approximation. And I'm getting that this is approximately, and let me carry it to 4. So we're looking at approximately 0.3178, which is our decimal approximation. I'm writing it to 4. Your expected value, it's technically the actual mean but rounded to the next integer. So in this case, or rounded to the nearest integer, sorry. Some problems do want you to round up, but in this case, I'm just going to use the regular rounding. So our expected value, it's technically 0.3178, which we would say that this is 0. And this is actually good because we're talking about 0 homicides. When we're reporting expected values, they are going to ask us for the units. Some of the problems may want you to round up to the nearest integer. So in that case, you would report 1 homicide, which is technically the average of what they're expecting. On the good news, the actual variance, it's also going to be the values of mu. So in this case, let me use the exact. So we're just going to say that this is the 116 over 365. And then for the standard deviation, this is going to be the square root of 116 divided by 365, which is equal to the following. Okay, I'm going to round to 4, so approximately 0.57, 0.56, 37. And that's rounding to 4 decimal places. The next part of the question is asking for the usual number. So in this case, we're going to talk about the usual interval. That actually represents how many homicides are expected from a min to a max. And let me use the decimal approximations. So the maximum value, it's going to be equal to technically 0.3178 plus 2 times the 0.5637 and 0.3178 minus the 2 times the 0.5637. And let me evaluate this. And on the lower bound, we're looking at negative 0.8096. On the upper bound, I'm getting that this is 1.4452. Let me check the evaluation. Okay, and then since we are going to end up with an interval, well, we cannot have negative homicides, so we're going to have to round to the nearest integer, or in this case 0. On the maximum, it's going to be 1. And then let me just write it as a sentence. The usual interval is technically 0 to 1 homicides. Not the best unit to work with, but that's what the problem from the author is giving us. And let me actually show you what the picture of this event looks like. I added this on the end, and you can see here that, well, the usual value, it's technically the maximum that is showing up. As the possible homicides increases, the probability of those are going to be 0. So unfortunately, in this city, they're expecting to see anywhere between 0 to 1 homicides within the given interval. In this case, the interval that we're using is the years. Actually, sorry, it's 1 year. Okay, let's move on to the evaluations. For the first evaluation that they're asking us to do is to find the probability that there's a total of 0 homicides. So evaluating this one, it's just going to be the probability of x is equal to 0. And let me show you the calculator. Okay, there we go. And we're going to be using, so in this case, it's going to be the Poisson PDF. The mean is 116 divided by 365, and we're doing a total of 0. And in this case, we're looking at 0.7277. I put the code there, so this is going to be approximately 0.7277. And remember that you're evaluating this as the values of the mean, and then technically this will be your x's. So you're punching in into the PDF mu and your x's. It is best for the homework questions to punch in the actual fraction exactly as it stands. Otherwise, evaluating the 0.3778 may give you a little bit of error. So that's actually it for 0 homicides. Let's evaluate 1 homicide. So since it's already been declared, we don't need to declare it again. So in this case, we're going to be evaluating that x is equal to 1. And in the calculator, we're just going to run the previous answer, but modify it to 1. And this is going to give us 0.2313, rounding to 4 decimal places. So approximately 0.23. And then 13. That's it for this one. Let's do one more evaluation. Now we're changing it to 4 homicides. So in this case, I'm just going to modify the previous answer. Notice I'm just modifying it to 4. And this one's really small. So this one, let me rewrite it. This is the probability of x is equal to 4. And the calculator is giving us a really small value. The e represents powers of tens. So this is going to be approximately 3.09 times 10 to the negative 4. That may be perfectly fine. If you are expressing it as a decimal, then you're going to have to count the actual zeros. So in this case, we're looking at 0.000, and then there's going to be a 309. Let me count them. So 1, 2, 3, 4, 0, 9. Okay, and that is pretty much it. So the powers of 10 to the negative 4 is how many places we moved it to the left. And in this case, we're moving it to the right. So 1, 2, 3, and 4. That would be the 3.09 times 10 to the negative 4. Both of these are perfectly fine. Let's take a look at E. Now, E, it's saying less than. So in this case, this is the probability of x is less than 5 homicides. And in this case, it's actually evaluating the probability of x is equal to 0, plus the probability of x is equal to 1, plus the probability of x is equal to 2, plus the probability of x is equal to 3, and then plus the probability of x is equal to 4. So remember that your random variable here represents integers. So if in this statement the wording is saying less than 5, this is equivalent to saying the probability of x is less than or equal to 4. And as we evaluate all of these, you would be using the CDF. Remember that for single evaluations, we're doing the PDF. That's for x is equal to a number. For less than or equal, CDF. So in this case, less than 5 means from 0 on to 4, and we're not including 5 or less than or equal to 4. So for this one, we're going to be evaluating the CDF 116, divided by 365, and we want to evaluate all the way to 4. And this gives us, well, almost technically 1. So let me just rewrite it. For this one, we're looking at 0.99. There is 4 nines, 1, 2, 3, 4. And then a 7. Actually, it should be an 8. Let me count again the ones, 1, 2, 3, 4, and then an 8. And technically, we're looking at the probability of almost 1. Now, if you look at the actual event, we're looking for less than 4. 4 is going to be out here, so technically it's almost the entire event. After the values of 2, there's almost no area. The probability of 3 or more homicides is really small. That's it for problem E, that is asking less than 5, and less than 5 is going to translate to less than or equal to 4. Now, let's take a look at another one, which is F. And F is saying more than 5 homicides. So the probability of X is greater than 5. And more than 5 means technically, it means the values of 6, 7, and all the way to N. And technically, we don't have an upper bound. Now, the sum of all of these, so the sum of P of X is equal to 1. And in this case, it's easier to evaluate the complement because we don't have an upper bound. We don't know where to stop. So this portion here, we wouldn't really be able to evaluate. And it's also going to be really small. So for this one, we will do the complement. And the complement is saying, well, 1 minus the probability of X is less than or equal to the values of 5. So in this case, we're going to run the previous event, but with the CDF of 5. And notice that that's going to give you almost the values of 1. So we're looking at this is equal to 1 minus, and I see a total of 1, 2, 3, 4, 5. So 0.999998. Actually, it should be a 9. Which is approximately the values of 0. And that's actually it for this one. In terms of the rounding, well, all of these are almost 9s. So we would get a small value, and that's because your main event here only occurs on the first, 0, 1, and 2 homicides. Anything beyond that, it's almost 0. That's actually it for this one, where we needed to use the complement.